One and two step inequalities. These work pretty much like one and two step equations. So if you're not sure how to solve those, then I have a video on one and two step equations. You might want to watch that first and do some practice problems there before you can get into one and two step inequalities. Now, there is a difference that I'm going to point out in the video when the situation arises. So let's start with some examples. So the first example, I'm going to say x minus 2 is greater than 5. So just like one step equation, we want to get rid of the negative 2 because we are trying to solve for x. So you won't have the variable by itself. To get rid of the negative 2, you want to add 2 on both sides. So you go ahead and add 2 on either side. Maybe draw a line through the inequality to keep things separated. Then on the left, this is just x. And on the right, 5 plus 2 is 7. So you get x greater than 7. The inequality was greater than, so I'm going to copy the greater than. Now, if this was equal to, I would have copied that equal sign. So absolutely no difference in the solution process for an inequality and equality. But there are some problems where things are a little bit different. So let's look at the ones that are easy enough. X plus 3 is less than, say, 10. So this time, to get rid of the plus 3, we subtract 3 from both sides. So let's do that. And then again, draw a line. On the left side, it's just x. On the right, 10 minus 3 is 7. So x less than 7. So that's our final answer. So these are one-step inequalities. Now let's look at a two-step inequality. So in two steps, there will be two operations. So say I have 3x minus 4 is less than or equal to 11. So look, in order to solve for x, we need to get rid of this term, the negative 4 first, and then we'll have to get rid of the 3. So it will take two steps. In the first step, I will get rid of negative 4 by adding a 4 on both sides. So plus 4 and plus 4 on either side. Draw a line through your inequality. Now on the left, the minus 4 plus 4 cancel each other out. We have 3x. On the right, it's 11 plus 4, which is 15. So that's our first step. And then we copy the inequality. Now finally, I still have to get rid of the 3 in front of x. So since 3 is multiplying with x, I will be dividing both sides by 3 because that's the inverse of multiplication. So if you divide both sides by 3, the 3's cancel out, and then what I'm left with is just x on the left, and on the right, 15 divided by 3 is 5, and I'm going to copy the inequality. So the solution method looks very much like one and two step equations. Now, where is the difference? The difference will be seen in example 4. So say I have 7 minus 2x is less than or equal to 4. So just like two-step equation, we want to get rid of this 7 first because the variable is here in this term, 2x. we want to get rid of the other term first. So to get rid of 7, since you don't see anything in front of 7, it means it has a plus sign. So I need to subtract 7 from both sides first. So let's do that. Subtract 7 from both sides. Then draw a line through your inequality. On the left, 7 minus 7, they cancel each other out. And then you are left with actually negative 2x. One mistake is to ignore the negative or just say that I only have 2x. But no, you actually have negative 2x. And on the right, it's 4 minus 7, which is negative 3. And just like before, you copy your inequality. Now, to solve for x, we still need to get rid of the negative 2. So we divide both sides by negative 2. Now, this is where inequalities work differently. Whenever you're dividing by a negative number, the inequality does not remain the same. It's going to flip. So greater than or less than or equal to will become greater than or equal to, and vice versa. So be sure to flip anytime you're dividing both sides by negative number. So on the left, I have x, and on the right, negative 3 over negative 2. Negative over negative is positive, so it's going to be positive 3 over 2. All right, let's look at one more example where it would be multiplying both sides by a negative number. So say I have 3 minus x over 2 is greater than 5. So first step is to get rid of the 3 because that's the term that does not have variable in it. The variable term is x over 2. So to get rid of that, we subtract 3 from both sides. Let's do that. Draw a line through the inequality. Now when you subtract or add, the inequality does not flip. So 3 minus 3 is gone. But notice you have negative x over 2. And on the right, you have 5 minus 3, which is 2. So you copy your inequality. Subtracting or adding does not flip the inequality. Now, in the next step, I need to get rid of this 2 and also the negative. So what do I need to multiply both sides by? Well, notice I have negative x over 2 and all I want is just x. So to get rid of the negative, I could multiply with negative, and to get rid of this 2 in the denominator, I need to multiply by 2. So I am multiplying both sides by negative 2. And when you multiply both sides by negative 2, your inequality is going to get flipped. Now, if this was confusing, let me explain the same problem one more way. Now, this way, it's just x and then is less than negative 4. Yeah, I think this explanation was somewhat confusing because we had both negative and a 2 in the denominator that we try to get rid of in a single step. So what I'm going to do is I'm going to explain it one more way where we'll go little slowly. So it's going to be the same example. I'm going to write 3 minus x over 2 greater than 5. Now the first step I hope is clear. Subtract 3 from both sides. Draw a line through your inequality. and then it's negative x over 2 greater than 5 minus 3 is 2. Now, let's get rid of the negative first. So to get rid of the negative, I'm going to multiply just by negative 1 on both sides. So if you multiply both sides by negative 1, what happens is negative times negative is going to be positive. Multiplying 1 and x will just give you x. So we are actually doing it in 3 steps because we are only getting rid of the negative sign first. So we need to get rid of the negative and also the 2. But we will get rid of only negative first. Negative times negative is positive, so I have just positive x divided by 2. And on the right side, it's going to be negative 2. Now notice, you're multiplying by a negative number, so that's where we said the inequality flips. So when does the inequality flip? When you either divide both sides by a negative number, or when you multiply both sides by a negative number. That's the only time the inequality flips. Now the inequality does not flip whenever you subtract on both sides or when you add on both sides. So adding and subtracting will keep the inequalities fixed, whereas multiplying and dividing will also keep the inequality fixed if you're dealing with positive numbers. But when you multiply or divide by a negative number, the inequality flips. All right, so this is what I have. X over 2. Now this time so I've already flipped it here. So it's x over 2 less than negative 2. And now I'm multiplying both sides by 2. So this time it's positive. So negative 2 times 2. So you get x less than negative 4. The same answer as we obtained earlier. Here we did it in 2 steps. Here we did it in 3 steps because I think it was a little bit confusing to get rid of both negative and 2 in the denominator in 1 step. So that's why I broke it down. Now, what we need is a lot of practice in order to get a good hold of them. So here I have the practice problems for this particular video, which is on 1 and 2 step inequalities. Remember, for 1 and 2 step inequalities, anytime you have to solve an inequality, the inequality does not flip if you are dealing with positive numbers. But when you multiply or divide both sides by a negative number, the inequality should be flipped. Now the answers to the practice problems will be in the description of the video. So good luck, and I'll see you in another video. Thank you.